Hello everyone. So welcome back. So the next problem is on hexagonal lamina. A hexagonal lamina of side 25 mm rests on HP on one of its corner. The lamina makes 45 degree with respect to HP and the diagonal passing through the corner on which the lamina rests is inclined 30 degree to VP. So draw its projections. So this is the given problem. Okay, first list out the data. Okay, here the given lamina is hexagon. The given lamina is hexagon of side 25 mm. Okay, here the given lamina is hexagon of side is 25 mm. It's a regular hexagonal lamina, means all sides are equal and all interior angles are equal. Next, note down the lamina inclination. The lamina inclination with respect to HP is 45 degree. Next, it is diagonal inclination problem. The diagonal incline with respect to VP is 30 degree. So these are all the given data. Okay, first check whether lamina resting on HP or VP. So in the problem, he has mentioned that the lamina resting on HP on one of its corner. Therefore, construct the top view of the lamina on horizontal plane. So when the lamina resting on HP, okay, here this is the horizontal plane. When the lamina resting on HP on one of its corner, first place the lamina completely on HP. Now look the lamina from top. Okay, here the true shape comes on HP. Therefore, start the first position with the true shape. So, okay, here why should I place the lamina HP? Because lamina resting on HP. Therefore, first place the lamina. Resting condition means ignore all inclination. Do not consider an inclination. Just to place the lamina completely on HP with a corner condition. The resting corner should come towards your left side. Okay, you should not place the lamina like this. Suppose if you place the lamina like this, so it becomes edge inclination. Sorry, edge resting condition. Now, place the lamina on HP, completely on HP. Now draw the top view and front view. This is the first position. To draw the first position, just I need this one. Lamina resting on HP with side of 25 mm. Now, okay, here I have constructed an hexagonal lamina. Okay, here with a resting edge on HP. So how to construct hexagonal lamina? So how to construct hexagonal lamina? First, draw a circle. Next, divide the circle into 4 equal parts. Next, take 25 mm dimension using compass. From this point, cut two arcs at a distance of 25 mm. Next, here also cut two arcs at a distance of 25 mm. Next, connect all the arcs. So we will get the hexagonal lamina with corner condition. This is the procedure for construction of hexagonal lamina with a corner condition. I have constructed hexagonal lamina with a corner condition. Indicate the dimension. Next, do the naming A, B, C, D, E and F. After completion of first position top view, to get the front view, draw vertical projection from all the corners to XY line. Now draw vertical projections from all the corners using thin line. Draw vertical upward projections. From all the corners to get the front view. Okay, here. So this is the front view of hexagonal lamina. Next, do the naming. Okay, here in the front view, this is the direction of view. A visible, that is A dash. B visible, F invisible. Therefore, B dash, F dash invisible, F invisible. Write it in the bracket. C visible, E invisible, then D visible. I have completed the first position, top view and front view by using this data. Only this data is enough to draw the first position, top view and front view. Just note down the resting condition and dimension. Next, since it is diagonal inclination problem, so draw diagonal. Since it is diagonal inclination problem, draw diagonal Using thin line, draw diagonal. So this is the true length of diagonal. Why it is called as true length? Because when the lamina parallel to HP or when it is placed on HP, the length of the diagonal will not get changed. So therefore, it is called as true length of diagonal. Okay, here the diagonal AD means, okay, here the diagonal passing through the corner on which the lamina rests means, okay, here point A is the resting corner. Therefore, I should draw the diagonal from point A only. You should not draw diagonal from B, C, D. You should draw diagonal only from point A because the point A is the resting corner. In the problem, he has mentioned that the diagonal passing through the resting corner on which it rests. So this is the diagonal passing through the resting corner A. Next, move on to the second position. To draw the second position, okay, here I need lamina inclination with respect to HP. So already I told you in the last classes. Okay, here this is the lamina. Okay, here when you rotate the lamina with 45 degree with respect to HP, the inclination is visible in the front view. The lamina inclination is visible in the front view. That is, the HP inclination visible in the front view. So front view comes on vertical plane. Therefore, okay, here I need to write the HP inclination. Right? Now, how to draw the second position front view? To draw the second position front view, just draw 45 degree line with respect to HP. So draw 45 degree thin line with respect to HP. Right? Next, redraw the first position front view. Just you redraw the first position front view because the length will not get changed. Now redraw the first position front view. Cut an arc to get point D dash. Next, measure the distance from A to C. Cut an arc, then measure the distance from A to B. Therefore, okay, here this is the point D dash and this is the point C dash and E dash and this is the point B dash and F dash and this one point A dash. So make it dark since it is the view, second position front view, make it dark. Next, draw vertical downward projections. Draw vertical downward projections using thin line. Projection lines means thin line. Draw vertical downward projections. Similarly, draw horizontal projections to get the second position top view. We can indicate the arrow marks. Right? Next. Okay, here do the naming by considering the intersection points of horizontal projections and vertical projections. Say example, so this is point A. So this is the horizontal projection of point A. Where is the vertical projection of point A? This one. Vertical projection of point A. Therefore, this is A, corner A. Similarly, this is the horizontal projection of point B. So this is the vertical projection of point B. Okay, here I will get point B. Similarly, horizontal projection of point C. Vertical projection of point C. Okay, here I will get point C. Horizontal projection of point D. Vertical projection of point D. Okay, here I will get point D. Horizontal projection of point E, vertical projection of point E, this is point E, vertical projection of point E, okay, here I will get point E. Horizontal projection of point F, vertical projection of point F, this is point F. Now, connect all the corners, so we will get the second position top view. That shape is called as apparent shape because when the lamina inclination, when the lamina inclined with respect to HP, okay, here the shape of the lamina gets changed because of inclination. Now connect all the corners. First connect A to B using dark lines, B to C, C to D, D to E, E to F and finally A to F. Now I have completed the second position, top view and front view. Okay, here this is the diagonal AD and this diagonal length is called as apparent length. Okay, here this diagonal length is called as apparent length. Why it is called as apparent length? Because when the lamina inclined with respect to HP, the length of the diagonal gets changed because of this inclination. When the lamina parallel to HP, the length of the diagonal will not get changed. Okay, that's why it's called as true length, and this is called as apparent length. Now, in the problem, he has mentioned that the diagonal passing through the resting corner, so is inclined 30 degree with respect to VP. So already we have discussed some beta angle problems. So when do we need beta angle? When the diagonal inclined with respect to VP, when the diagonal inclined or when the perpendicular bisector and the median inclined with respect to VP, then we need to find out beta angle. So how to find out the beta angle? So the procedure is already discussed. Okay, here, so beta angle, so just draw in a horizontal line, right? Next, so draw 30 degree line. So draw 30 degree line with respect to VP, draw 30 degree line with respect to VP angle phi, right? Next, measure this length, measure the true length, measure the true length. So measure the true length and from this point, cut an arc, extend, this is A and D. So let it be AD1, for my reference, let it be AD1. Now, okay, here, this is the true length. So this is the true length and this is the true inclination, right? Okay, here draw 30 degree line. Next, measure the AD length and from this point cut an arc. Now through point to D, draw a locus line. Draw a locus line. Next, measure this length. Measure this length. Next, from point A, cut an arc. So this is A D1. Now connect this one, A to D1. So if you measure, this is the apparent length. Now if you measure this angle, it will be equal to 44 degree. It will be equal to 44 degree. Now I have got the beta angle for this apparent length. Now you have to redraw this diagram by placing the diagonal AD1 and beta angle line. So how to draw the beta angle line? So okay, here draw beta angle line. So we know the beta angle, how much? 44 degree, which is equal to beta. This is the apparent length. Now you have to redraw the diagram. So you have to redraw the diagram by placing the apparent length of AD1 on beta angle line. So for that, first you measure this length. AD1. Now fix it on beta angle line. So AD1, this is the apparent length of diagonal. Just I have fixed this length AD1 on beta angle line. Next you have to redraw the remaining points. Say, measure this distance from A to F. I know the position of A, so just cut an arc. Then measure the distance from, I know the position of D, measure the distance from D to F, D1 to F. So D1 to F, cut an arc to get point F, right? Similarly, measure the distance from, A to B, measure the distance from A to B, cut an arc. Next, measure the distance from D1 to B. So okay, here I know the position of D1. Measure the distance from D1 to B, D1 to get point B. Right. Next, similarly measure the distance from A to E. Cut an arc. Measure the distance from D1 to E. So D1 to E to get point E. Similarly, so measure the distance from A to C. So A to C, cut an arc, measure the distance from D1 to C. D1 to C, cut an arc to get point C. Now connect all the corners. So we will get the diagonal inclination with respect to VP. So using dark lines. Okay, here I have just redraw this diagram by placing the diagonal AD1 on beta angle line. Next, just to draw the upward projections and horizontal projection to get the final view. So draw the horizontal projections and upward, so vertical upward projections. First, okay, here I am drawing the horizontal projection from the second position front view using thin line. So draw horizontal projections. So now draw vertical upward projection from all the corners. Vertical projection from point A, vertical projection from point B, okay, here I have drawn the projections, vertical projection from all the 6 corners. Now do the naming by locating the intersection points of horizontal projections and vertical projections. Say example, so this is the vertical projection of point A. So where is the horizontal projection? Okay, here we have horizontal projection, therefore this is A dash, since it is front view, A dash. Then vertical projection of point B, horizontal projection of point B, okay, here we have B dash. Then vertical projection of point C, horizontal projection of point C, okay, here we have C dash. Vertical projection of point D, horizontal projection of point D, okay, here we have point D dash. Vertical projection of point E, horizontal projection of point E, okay, here we have E dash. Finally, vertical projection of point F, horizontal projection of point F, okay, here we have point F dash. Now connect all the 6 corners to get the final front view. Connect using dark lines A to B, B to C, C to D, D to E, E to F, and finally F to E. So this is the final front view of hexagonal lamina. Okay, here the final front view shows when the lamina inclined 45 degree with respect to HP and the diagonal inclined 30 degree with respect to VP. Okay, here the 30 degree given in the problem, that is this inclination is for the true length. Okay, here I need to find out the apparent length. So I need to find out the inclination for this apparent length. So that's why, okay, here I need to find out the beta angle. So for that beta angle, you are supposed to place the diagonal AD1 on beta angle line. So this is the front view and top view of the hexagonal lamina. Okay, so in the next problem, hexagonal lamina of side 25 mm rests on one of its corner and HP. The lamina makes 45 degree with respect to HP, and the diagonal passing through the corner on which it rests appears to be inclined. This word is very, very important. Appears to be inclined 30 degree with respect to VP. Draw its projections. So this problem is almost similar to the previous problem. So the main difference is, okay, here the lamina resting condition is same. The lamina resting on HP with one of its corner. The lamina inclination is also same. The lamina inclination 45 degree with respect to HP. So that is also same. But the main difference between this problem and previous problem is, okay, here the diagonal appears to be inclined to VP at 30 degree. That's all. Now, as usual, First, note down the type of the lamina. The type of the lamina is hexagon upside 25 mm. The lamina resting on HP and one of its corner. So this data is enough to draw the first position. Okay, here I have already drawn the first position. So okay, here, so draw the hexagonal lamina by taking corner condition. So already we have discussed in the previous problem. Now draw the first position, top view and front view. Next, to draw the second position, I need HP inclination. Okay, note down the lamina inclination with respect to HP. The lamina inclination with respect to HP is 45 degree. So this data is enough to draw the second position. Now draw the second position. So procedure is same as that of previous problem. Okay, here up to second position, the procedure is same. Okay, just you refer previous problem, how to draw the second position, top view and front view. Now, so the diagonal, the diagonal passing through the corner on which it rests appears to be inclined to VP at 30 degree. Okay, here when the problem contains the word appears, you no need to find out beta angle or alpha angle. So why? Because in the problem he has given the apparent length, apparent inclination for this length. Okay, here this is the apparent length, and for this apparent length the inclination is given. The directly he has given the apparent inclination. Therefore, you no need to find out beta angle. Okay, here beta angle is not needed. When the problem contains the word appears, you no need to find out any beta angle. That is apparent inclination, because in the problem he has given the apparent inclination. So that's why, okay, here for this apparent length, the angle is given how much? 30 degree. Therefore, you just you draw the 30 degree line. Draw 30 degree line with respect to VP. Now, just you redraw this lamina directly without finding any beta angle by placing the diagonal AD1 or AD. So on 30 degree line. So already we have discussed the procedure how to redraw this lamina. Right? Just you go through the previous problem. Now just you redraw this lamina on 30 degree line without finding any beta angle. But in the problem he has given the beta angle. Next, just you draw vertical upward projections and horizontal projection to get the final view. So the problem is similar to the previous problem. The main difference is, okay, here the diagonal appears to be inclined with respect to VP. So that's why, okay, here I am not finding the beta angle. Just I have redrawn this lamina. I have redrawn this lamina by placing the diagonal AD directly on 30 degree line. So this is the major difference between previous problem and this problem.